Viewers, and welcome back to for final maths class. Today we are going to look at a very important topic in mathematics called indices, which cut across in most of the topics in mathematics. Okay, now index form or index notation is a simple way to write numbers. Okay, so for example, if you have the number 3 to the power 4, okay, this number is in index form. Okay, and then the small 4 which is at the top, okay, the 4 which is at the top is known as the power. Okay, and then it can also be called exponent, and lastly it can also be called the index. Okay, so the small 4 on top of this expression, it can be called the power, the exponent, or the index. Okay, and then the 3 is known as the base, and then the base. So if you look at this expression, it can be read as 3 index 4, or 3 power 4, or 3 exponent 4. Okay, and then the index or the power or the exponent is telling us how many times the base is multiplying itself in indices. Okay, so this one, for instance, we have base 3, it means to the power 4, it means 3 is multiplying itself 4 times, like this. Okay, so if you look at this value, okay, this value will give us 81. All right, so writing this 81, you can simply write it as what? 3 power 4. Okay, so if you have an expression like a to the power 4, or let's say a to the power 3, all right, simply in indices or in index notation, it can be written as what? A times a times a. The power is showing us how many times a is multiplying itself, and then the a is the base. Okay, so you could have a number like 3 to the power, say, 5. Okay, 2 to the power 5. It is telling us that 2 is multiplying itself how many times? 5 times. So you could have 2 times 2 times 2 times 2 times 2. Okay, so you could have 1, 2, 3, 4, 5. It means 2 is multiplying itself 5 times. Okay, we have certain things that we have to note. This that I've written, 3 to the power 4, it is read as 3. Okay, 3 is read as what? 2 is 3 is raised to the power 4, or 3 index 4, or 3 exponent 4. That is how it is read. Okay, and then the other thing that we have to also note is that a number to the power 2 is usually called square. All right, it's usually called square. So if, let's say, you have 3 to the power 2, it means 3 square. Instead of saying 3 to the power 2, you can also say 3 square. And then also, if a number is raised to the power 3, it is also read as what? 3 cube. So instead of saying 3 to the power 3, or 3 exponent 3, or 3 index 3, you can read it as what? 3 cube. Okay, so if it is a cube, it is x cube. And if it is the square 2, it will be a squared, b squared. Okay, that is how they are read. All right, and then any number without any index is also known to be raised by power 1. Okay, so if you have any number standing alone without any assigned power, what it means is that particular value or that particular number is raised to the power 1 naturally. Okay, so you need to know that any number which stands alone by itself is raised to the power 1. So when you see the number written without any assigned power, it means that it is raised to the power 1. And then the next thing that you have to also notice is any number raised to the power 0. So any number raised to the power 0, say 2 to the power 0, is equal to 1. All right, so if the earlier you know these rules, the better. All right, so you will be meeting this kind of rules or this kind of informations in your calculations when you are dealing with what? Indices. You will be somewhere, and then you have something like this, which is 2 to the power 0, or it could be even 100 to the power 0 is still what? 1. Whatever value that you have, if it is even billions and it is raised to the power 0, the answer is supposed to be 1. And then the next thing that I would like us to also take note is that a negative index has a special way of expressing it. So if a number is raised to the power a negative value, it has a special way of writing. So let's say if you have 2 to the power negative 1, all right, the special way of expressing this is reciprocating the base. all right, to get rid of the negative sign. So reciprocating the base means, so this one actually we know it is divided by 1. So reciprocating means you somersault it. You bring the denominator up and then the numerator down. So you get 1 over 2. All right. So if you have 3 to the power negative 3, okay, you reciprocate. In order to get rid of the negative sign, you reciprocate the base. So you get 1 over 3 to the power 3. You have gotten rid of the negative sign. So these are the things that you have to get, you have to note when you are dealing with indices, okay? So without wasting much time, let's move on to one more important thing, which is the laws of indices. The laws of indices, all right, which is very essential if you are dealing with indices or if you are tackling an indices question. The first law says that when you have a base raised to the power a certain value and it is multiplying the same base raised to the power a certain value as well, okay, so you have the same base here and they are raised to the power a certain numbers and they are multiplying. So you have here a to the power m and then a to the power what, n, and they are multiplying. Since the base are the same, the first law of indices says that you can take one of the bases and then you add the powers. Okay, so you take one of the bases, then what, you add the powers. An example is if we have 2 to the power 2 multiplying 2 to the power 5. Since these bases are the same, you take one of the bases, then you add the power. So you'll be getting 2 to the power 7. All right. Now let's move on to the next rule. The next rule also says that if you have a base raised to the power a certain value and it is dividing the same base raised to the power another value, okay, the second rule says that you can take one of the bases, then you subtract the powers. Okay, with the multiplication, you take one of the bases, then you add the powers. But with the division, when you have the same bases dividing each other, then you do subtraction with the powers, all right? So now the third rule, okay, but let me give an example here first before we move on to the third rule. So if you have 3 raised to the power 6 dividing 3 raised to the power 3, all right? 3 raised to the power 3. What you can also do here is you take one of the bases, then you subtract the powers, all right? So if you have 3 to the power 6 minus 3, you'll be getting 3 to the power what? 3. All right, so this is what is meant by this rule, okay? Now let's move on to the third rule. The third rule also says that when you have a certain base raised to the power a certain value, all right, and then all of them, okay, putting in bracket, are also raised to the power another value. All right, so we have here a raised to the power m into bracket raised to the power n. The rule says that the powers can multiply each other because when you look, they are the one outside the bracket will come inside and multiply the power, which is what, inside the bracket. So you will be realized that we have m multiplying n. All right, so the value or the answer will be what, a raised to the power mn. Okay, so a quick example will be, say we have 2 to the power, say 2 to the outside the bracket, we have power 3. All right, so the rule says that these 2 will multiply what, the 3 outside the bracket, and it will be equal to what, 2 to the power 6. All right, that is the third rule, what the third rule says. Now the fourth rule also says that if you have a value a raised to the power a certain value, say x, multiplying y to the power b to the power y, and they are enclosed in a bracket and they are also raised to the power another value outside the bracket, okay? The rule says that the one outside the bracket, the index or the power or the exponent outside the bracket will multiply each of the exponents inside the bracket. So if we should expand this bracket, you'll be getting a to the power nx times b to the power ny. So if you can realize what I've just written here, it means that this n, which is outside the bracket, which is also the power affecting those in the bracket, is multiplying each of the powers in the bracket, okay? So a quick example is, say you have 3 to the power 2 times, say, a to the power 3, all right? And then outside the bracket, we have power 2 here. All right, so here you realize that this 3 the exponent at the 3 will multiply the exponent outside the bracket times this a, the exponent of it will also multiply what? The exponent outside the bracket. So we'll be getting what? 3 to the power 4 times a to the power 6. All right, so that is what the fourth rule says. All right, now let's quickly take examples. All right, so I think we will stop here, and then in our next video I will try my best to give examples which concerns this rule, okay, which has to do with this rule in the next video. So don't forget to hit the like button if you have not done that, and if you are not followed, make sure you follow for more exciting videos. Have a nice day.